Basically, we have two methods to add and subtract vectors. The first method is graphical method of vector addition. That is already what we have discussed in the previous video. Today, we will see the second method, which is algebraic or analytic method of vector addition. So, under this method, we have three cases. So the first case is adding collinear or parallel vectors. The second case is adding or combining perpendicular vectors. And the third case is adding neither parallel nor perpendicular vectors. ስለዚህ በዛሬው ቪዲዮ አልጀብሪክ ሜተድን በመጠቀም እንዴት ቬክተሮችን ማትማቲካሊ ኮምባይን ማድረግ እንደምንችል አብረን እናያለን። አብራችን ሆኑ። Okay, let's see the first case. So when you combine two and more than two collinear or parallel vectors, the magnitude or the size of the resultant vector is the summation of all the vector which is acting in a given system, and its direction is acting in the directions of the represented larger vector. Let's see an example. For instance, let's say this is vector A with magnitude of 3 Newton, and if we have another vector plus vector B which is acting in the same direction to that of the first vector which is vector A, vector B which is the same as, let's say, 6 Newton. ስለዚህ vector A 3 Newton to the right, in the second vector which is vector B which is acting in the directions of vector A with a magnitude of 6 Newton. So the summation of the two vectors is acting in the directions of vector A or vector B, and their magnitude is the summation of the two vectors. So 3 Newton plus 6 Newton, which is what? 9 Newton, which is the summation of the two, which is R or the resultant. ስለዚህ የሁለቱ ቬክተሮች ድምር 9 Newton. So in this case, vector A and vector E is acting in the same direction. So what will happen if the two vectors are acting in opposite direction? ስለዚህ let's say this is vector A which is 3 Newton plus, and vector B is acting in opposite direction to that of vector A with magnitude of 6 Newton. So in this case, the two vectors is acting in opposite direction. So if they are acting in opposite direction, so the summation of the two vector is 6 Newton minus 3 Newton, which is what? 3 Newton, and the directions of the resultant vector is acting in the directions of the represented larger vector. ወደ ትልቁ ቬክተር አቅጣጫ ይሆናል ማለት ነው። ስለዚህ the magnitude of the vector is 3 Newton, which is resultant, and its direction is acting in the directions of what? The represented larger vector. ወደ ትልቁ ቬክተር አቅጣጫ አክት ያደርጋል ማለት ነው። አክት ያደርጋል ማለት ነው። So this is all about how to combine collinear or parallel vectors. Okay, the second case is adding perpendicular vectors. How to combine if the vectors are acting at right angle with each other. ስለዚህ ሁለት ቬክተሮች at right angle አክት የሚያደርጉ ከሆነ እንዴት ነው የሁለቱም ቬክተሮች ድምር ውጤት ማግኘት የምንችለው? When you combine perpendicular vectors, the size or the magnitude of the resultant vector is determined by using Pythagoras theorem, whereas its direction is determined by using trigonometry or trigonometric identity. Let's see. For instance, let's say this is vector A and this one is vector B, which is acting at right angle with each other. This is vector A and this one is vector P. So the two vectors acting at right angle with each other. So the summation of the two vector or the resultant vector is acting or drawn from the tail of the first vector to the head of the second vector. So this one is the hypotenuse. Hypotenuse, or let's say C, abbreviate scenario. This one is the adjacent side, and this one is opposite side if it is theta. ይሄኛው theta ከሆነ this one is the adjacent side, this one is the opposite side, and this one is the hypotenuse side. So the two vectors are acting at right angle with each other. ስለዚህ ሁለቱ ቬክተሮች at right angle with each other act እስካረጉ ድረስ we can use Pythagoras theorem to determine the resultant of the two vectors. So the resultant, which is the summation of the two c square, is equals to vector a the whole square plus vector b what? The whole square. This is all about Pythagoras theorem. Pythagoras theorem. So Pythagoras theorem states that the opposite side, the whole square, is the same as adjacent side, the whole square, plus what? The opposite side, the whole square. If the two vector, which is vector A and vector B, is acting at right angle with each other, simply we can use Pythagoras theorem to determine their magnitude or size. To determine the directions of the resultant vector, so this is the resultant vector. So let's say angle theta magnet. Simply we can use trigonometry. Sine theta is equals to opposite side over what? The hypotenuse side, where the opposite side is what? Vector B, magnitude of vector B over what? The hypotenuse, which is the resultant or C. And cos theta is equals to adjacent side over the hypotenuse side, where the adjacent side is vector A over the hypotenuse, which is C. And you can use alternatively tan theta, which is the same as sin theta over min cos theta. ስለዚህ rearrange ስታረጉት ምን ይሆንላችኋል? opposite side over adjacent side. Opposite side or adjacent side, which is the same as the opposite side, which is vector B, magnitude of vector B over magnitude of vector A አርጋችሁ አንግሉን ማግኘት ትችላላችሁ። አንግሉን ካገኛችሁ በኋላ ከሆሪዞንታሉ በዚህን ያህል ዲግሪ ከፍ ብሎ ይገኛል፣ ዝቅ ብሎ ይገኛል እያላችሁ ዳይሬክሽኑን ጀስቲፋይ ማድረግ ትችላላችሁ ማለት ነው። So this is all about how to combine perpendicular vectors. Let's proceed to the third one. Vectors. To combine neither parallel nor perpendicular vectors, simply we can use component method. To combine vectors by using component method, first of all, we have to resolve all the vector into its horizontal and vertical component. And then we have to sum up all the vectors along the horizontal and along the vertical. And finally, we can find the resultant vector by using Pythagoras theorem. Okay. ስለዚህ ኮምፖነንት ሜተር ላይ ምንድነው የምናደርገው? ሁሉንም ቬክተሮች በመጀመሪያ ደረጃ ሪዞልቭ እናደርጋለን። Resolving means what? Splitting a vector into its horizontal and vertical component. ስለዚህ along x እና along y ሁሉንም ቬክተሮች ሪዞልቭ አድርገን ወይንም ለያይተን ከጨረስን በኋላ ሆሪዞንታሊ አክት የሚያደርጉትን ቬክተሮች ለብቻ አንድ ላይ እንደምራለን። ከዛ along the vertical አክት የሚያደርጉትን ለብቻ እንደምራለን። ከዚህ በኋላ ሪዛልታንት along x እና ሪዛልታንት along y ይሆንልናል ማለት ነው። ሪዛልታንት along x ማለት the summation of all the vector which is acting along x and resultant along y ማለት the summation of all the vector which is acting along y. ስለዚህ we have what? Two perpendicular vectors, resultant along x and resultant along y. ከዚህ በኋላ ሪዛልታንቱን ለማግኘት ምንድነው የምናደርገው? Pythagoras theorem. That's why the two vectors is what? Acting at right angle with each other. ከዛ በኋላ ዳይሬክሽኑን ለማግኘት ደግሞ tan theta መጠቀም ይኖርብናል ማለት ነው። So there is an example which is related with this. Let's see. The displacement of 10 kilometer makes 30 degree with x-axis, and the displacement of 20 kilometer makes an angle of 120 degree with x-axis. So the question is find the resultant displacement it says. ስለዚህ እንደዚህ አይነት ጥያቄ ሲሰጣችሁ በመጀመሪያ ደረጃ you have to draw the free body diagram and then combining the vectors by using what? Algebraic or analytic method, or by using component method. Okay, let me draw the free body diagram. This is x-axis and this one is y-axis. So the displacement of 10 kilometer which makes 30 degree with x-axis 10 kilometer ከሆሪዞንታሉ በ30 ዲግሪ ከፍ ብሎ ይገኛል ነው የሚለው። So let's say this is vector A with magnitude of 10 kilometer at an angle of 30 degree to the horizontal. ከሆሪዞንታሉ በ30 ዲግሪ ከፍ ብሎ ይገኛል። And the second vector is 20 kilometer which makes at an angle of 120 degree with x-axis 120 degree ከሆሪዞንታሉ። ስለዚህ 120 degree ማለት ከዚህ እስከ ስንት ነው? 90 degree. So 90 plus 30 which is 120 degree, right? So the vector is acting at this point. So this is the second vector. The second vector which is vector B አይደለ? Which is 20 kilometer. ስለዚህ ከዚህ ስንት ዲግሪ ነው ማለት ነው? 120 degree. ስለዚህ እቺኛዋ ስንት ነች ማለት ነው? 60 degree. 60 degree. So this is vector B. So now this is all about the free body diagram. አሁን የመጀመሪያው ስቴፕ ምንድነው? ፍሪ ቦዲ ዲያግራሙን ማስቀመጥ። ከዛ በኋላ ምን ብለናል? resolve all the vector along its horizontal and vertical component. ስለዚህ resolve ስናደርግ ምንድነው? Let's say this is the vertical component of vector A which is AY. ከዚህ this is horizontal component of vector A which is AX. And this one is BY which is acting along the vertical. And this one is BX. ችኛዋ ምን ሆነችልን? BX ሆነችልን ማለት ነው። ስለዚህ አሁን BX is acting in the directions of what? Negative X axis. ስለዚህ ወደ negative X አክት የምታረግ ከሆነ መጨረሻ ላይ ማይነስ ማድረግ ይኖርብናል ማለት ነው። So by using trigonometry, you know, sin theta is equals to, so let me resolve vector A. ስለዚህ አሁን already free body diagramን አስቀምጠናል። ከዚህ በኋላ ምን ብለናል? resolve ማድረግ. So to resolve the vectors, sin theta is equals to opposite over min hypotenuse. So sin theta is equals to the opposite side which is AY over hypotenuse vector A which is 10 kilometer አይደለ? Vector A አይደለ? So when we recode this one, AY is equals to vector A times sin theta. Then AY is equals to A ስንት ነው? 10 kilometer times sin 30 degree. sin 30 0.5 ሲባዛ በ10 ስንት ይሆናል? 5 ኪሎ ሜትር። ስለዚህ ቬክተር ያለው y 5 ኪሎ ሜትር ነው ማለት ነው. which is positive. That's why AY is acting along in the positive y axis. Which is what? Positive. እሺ. And then to determine or to resolve vector along x, we can use cos theta. Cos theta is equals to adjacent side over hypotenuse, which is the same as ax over the hypotenuse, which is vector A. So when we recode this one, ax is equals to vector A times cos theta. Then ax is equals to vector A which is 10 kilometer times cos 30 degree. Then ax is equals to cos 30 0.86. 0.86 multiplied by 10 which is 8.6 kilometer along positive x-axis. This also positive. So vector A is already resolved. ስለዚህ vector A resolve አድርገን ጨርሰናል ማለት ነው. Next we have to resolve the second vector which is what? Vector B. So to resolve vector B, you know, sin theta is equals to opposite over hypotenuse which is by over the hypotenuse which is vector B which is what? 20 kilometer. ስለዚህ by ስንት ሆነልን? by ስንት ሆነልን? 20 kilometer times sin how much degree? 60 degree. Sin 60 degree. Then by is equals to 20 kilometer multiplied by sin 60 which is 0.86. ስለዚህ ቬክተር ቢ along y is equals to ስንት ይሆናል? 17.2 kilometer, which is what? Positive. That's why by is acting along positive y-axis. And then cos theta is equals to adjacent over hypotenuse. The adjacent side is bx over the hypotenuse, which is vector b 20 kilometer. Then bx is equals to 20 kilometer times cos 60 degree. Then bx is equals to 20 kilometer 20 kilometer multiplied by cos 60, which is 0.5. Then bx is equals to, how much is it? 10 kilometer, which is what? Negative. That's why the horizontal component of vector b is acting in the directions of negative x-axis. Negative x-axis. So when you sum up all the vector which is acting along x, we have to make what? Minus this one. So the resultant vector along x is equals to ax plus min bx, where x is 8.6 kilometer plus bx, which is minus 10 kilometer. Then resultant along x is equals to minus 1.4 kilometer. Okay, ስለጠፋነው እንዳንረሳው resultant along x is equals to minus 1.4 kilometer. So resultant along y is equals to vector along y plus vector b along y, where ay is 5 kilometer plus by 17.2 kilometer. So resultant along y is equals to 22.2 kilometer. Okay. If it is all about resultant along x and along y, let me draw the free body diagram. This is resultant along x, which is 1.4, which is acting in the direction of negative x-axis, and resultant along y is positive, so we have to draw seems like this. This is resultant along y, which is 22.2 kilometer. So the resultant vector is acting or drawn from the tail of the first to the head of the second. በዚህ መልኩ ድሮው እናደርገዋለን። ስለዚህ ይሄኛው ምን ይሆንልናል? resultant. So this is the directions of the resultant vector. ስለዚህ ይሄኛው xy ፕሌናችን ከሆነ resultant ቬክተሩ ከሆሪዞንታሉ በዚህን ያህል ዲግሪ ከፍ ብሎ ይገኛል የሚለውን ዲተርማይን ለማድረግ አንግሏን በቀላሉ ማግኘት ትችላላችሁ። ስለዚህ ኦሬዲ ሪዛልታንቱን ለማግኘት ሲምፕሊ we can use Pythagoras theorem. Resultant square is equals to rx the whole square plus ry the whole square. ስለዚህ resultant r is equals to under square root of this one, resultant along x, which is minus 1.4 the whole square plus resultant along y, which is 22.2 the whole square. So the resultant r is equals to under square root of ይችኛዋን ስኩዌር አድርጋችሁ ስትደማምሩት 494.8 ኪሎ ሜትር ይመጣል። ስለዚህ ከራዲካል ስታወጡት resultant r is equals to 22.3 kilometer. So this is the resultant vector or the summation of the two vector. ከዚህ በኋላ ምንድነው የቀረን? The directions of the resultant vector. To determine the directions of the resultant vector, we can use tan theta. So tan theta is equals to the opposite side over what? The adjacent side, which is resultant along y over resultant along x. Resultant along y, which is 22.2 kilometer over resultant along x, which is 1.4 kilometer. So let's ታካፍሉት. So tan theta is equals to 15.8 5 ይመጣልናል። then theta is equals to tan inverse of 15.85. So 15 tan inverse of 15.85 is the same as 86.4 degree. ስለዚህ ሪዛልታንት ቬክተሩ ሆሪዞንታሉ በ86.4 ዲግሪ ከፍ ብሎ ይገኛል። ኦር ስለዚህ ከ90 ላይ 86.4 ስትቀንሱ 3.6 90 ላይ ደምራችሁ ከኤክስ አክሲስ 93.6 ዲግሪ ርቆ ይገኛል ብላችሁ ማስቀመጥ ትችላላችሁ። ስለዚህ ፋይናሊ መልሳችሁ ምን ብላችሁ ማስቀመጥ ትችላላችሁ? the resultant vector r is equals to 22.3 kilometer at an angle of 93.6 degree with x axis axis ብላችሁ ማስቀመጥ ትችላላችሁ። ወይንም the resultant vector is 22.3 kilometer at an angle of 86.4 degree above negative x axis ብላችሁ ሪዛልታንታችሁን ማስቀመጥ ትችላላችሁ ማለት ነው። so this is all about combining vectors mathematically or by using algebraic or analytic method። ስለዚህ የዛሬው ቪዲዮአችን ይሄን ይመስላል። አጠቃላይ እዚህ ጋር ስንሰራ ያልገባችሁ ነገር ካለ ወይንም ተጨማሪ ኤግዛምፕል እንዲሰራበት ከፈለጋችሁ ኮሜንት ላይ አስቀምጡልኝ። አመሰግናለሁ።